Section 7.1, we're going to start to talk about bonding, and specifically ionic bonding. So bonding is when electrons are transferred and not shared. All right, so the chemical bond, what is a chemical bond? Well, the definition is that it is a strong attractive force between atoms in a molecule. So it's just a force that can hold them together, and it can be different types of forces depending on the bond. There are 3 different types of bonds. There's ionic, which we're going to be talking about in this unit, also metallic, we'll talk about that briefly too, and then covalence. So we're going to talk about 3 different types of bonds. The ionic bonds are specifically, they're bonds between metals and nonmetals. So remember our periodic table, all the metals are over on the left and the nonmetals are kind of over on the top right. So it's going to be between those 2 type of elements or more. Metallic compounds are just bonds between metals themselves, and then covalent compounds are bonds between the 2 nonmetals. Okay, and we're going to talk about that in the next unit. So here are some different compounds, all right? And you can actually predict what type of bond they're going to make by the elements in them, all right? So let's look at the first one. So the first one is magnesium and chlorine together. So magnesium is a metal, chlorine is a nonmetal, so this will be ionic. All right, let's look at the next one, nitrogen and hydrogen. Now, even though hydrogen is over on the left, it is still a non-metal. They just put it on the left because of the electron configuration. So this one is actually 2 nonmetals, so it will be covalent. All right, next one, iron and Hg, Fe is iron, and Hg is mercury. All right, so these are 2 metals. They're actually 2 transitional metals, so this is going to be a metallic bond. All right, next one, cesium and oxygen. All right, so if you guys remember, cesium is all the way over in group 1, and oxygen, so it's a metal, and oxygen is a nonmetal, so this is once again going to be ionic. It'll be one of those we're talking about this unit. And the next one, hydrogen, carbon, and oxygen. So if we look at all 3 of those are nonmetals, so this will also be covalent. Okay, all right. So let's go ahead and specifically now talk about ionic bonds, so bonds between metals and nonmetals. All right, so this is the property. So an example of an ionic bond is sodium chloride, NaCl over here, and it has some specific properties. So we'll look at this in a lab also. The first one is that they form crystals. So they're crystalline. This means that they are brittle, all right? So this sodium right here is a positive charge, actually, and the chlorine has a negative charge on it. So they don't want to move past each other. So that makes them that if you put a force on it, it'll just break rather than bending, so they are brittle. They have high melting points because that's a pretty strong attractive force, and the crystals are large, right? And that's due to the crystal structure. And they can conduct electricity in water or when melted. So they don't conduct electricity when they're in a solid state like metals, but they can conduct electricity in water or when melted because they're formed by ions. So the crystalline structures. So all ionic compounds form large crystal structures, and they have different types depending on what it is. You can see sodium chloride here. We just talked about that. It's a regular structure with sodium at one point and then chlorine at another point in a cube. All right, but other things have different structures. If you look at like calcium fluoride right here, the calciums are the orange ones, and the fluorine are the blue. You can see that they have a different structure that's not regular. Cesium chloride has a pretty regular structure, so it has the cesium in the middle here with the chlorine all around. And then this one, calcium titanium oxide, has a structure like that. So that's what it might look like if there's more than 2 elements in the compound. So the crystal gives the structures of being brittle and having a high melting point because you cannot move past the atoms, cannot move past each other easily. They're stuck where they are, and they'll just break. All right, so what holds the atoms together in an ionic bond? Well, it's actually a bond is formed by the electrostatic attraction. What that means, electrostatic attraction, it means attraction between positive and negative. So we've talked a lot about magnets in here and positive and negative and how positive and negative are attracted to each other. That's what holds things together. It's called electrostatic attraction between oppositely charged ions. Okay, and if you guys remember, an ion is just a charged atom. So sodium has a +1 charge here, chlorine has a -1 charge here, and this electrostatic force keeps them attracted together. What happens to make the ions is that the electron is actually transferred from one atom to another. So sodium is positive, chlorine is negative, so the electron went this way. So remember, electrons have a negative charge. So the sodium actually gave its electron to the chlorine there. And then it makes the bond. All right, and we will watch this in class, and that is it for this section.